Welcome to your final lesson. We're doing the final exam practice at least. This is in the announcements on Canvas. You can find it. I condensed it down so you don't have 15 pages. I realized I should have put one up where there's like blank spaces so you can practice, but I didn't. So maybe I'll do that this afternoon. The first three problems are limit problems. So chapter 1 stuff. You have to use L'Hopital's on at least one. I think L'Hopital's is pretty easy and easier than doing some of the limit shit. But it's up to you. That should be an x squared there. 2x minus 4x squared over 7x squared plus 8x minus 5. The limit is x goes to infinity. If we plug in infinity, we're going to get infinity over infinity. So this is a candidate for L'Hopital's. So the L'Hopital's approach would be take the derivative. And we get 2 minus 8x over 14x plus 8. Again, that equals infinity over infinity, so we can L'Hopital again. And you have a limit as x goes to infinity of -8 over 14. And that's what the answer is, -8 over 14, which reduces to -4/7. Alternatively, another way to go about doing this one multiply each by the 1 over x to the power of the biggest term on bottom. This would be 2 over x minus 4 over 7 plus 8 over x minus 5 over x squared. And as x goes to infinity, these terms go to 0. Only as you take the limit. And you get -4/7, which is all you had left over. Any questions on that one? Next one's actually a pretty easy candidate for L'Hopital too. So the L'Hopital approach, if you plug in 3, you get 1/3 minus 1/3 over 3 minus 3, which is 0 over 0, which makes it eligible for L'Hopital. It's an indeterminate form. The derivative of the top, the derivative of 1 over x, so this is x to the -1 minus 1/3. If I take the derivative of x to the -1, I have -1 over x squared on top. On bottom, I just have 1, and I need to put my limit in there. I need to have the limit each time. And now when you evaluate at x equals 3, you just get -1 over 3 squared, which is -1/9. The alternative is cleaning this up. This if you get a common denominator here, you have 3 minus x over 3x all over x minus 3. And we still got limit as x goes to 3. And then you multiply by the reciprocal of the bottom. And 3 minus x cancels x minus 3, leaving a negative 1. On bottom, we just have 3x from there. And this part just cancels. And we're doing the limit as x goes to 3. Negative 1 over 3 times 3 is negative 1/9. Guys ready for some more? All right, next one. We had a formula that had sine. Remembering that fucking formula is a pain in the ass. I know it was sine x over x. I want to say it equaled 1, but we don't have sine x on top or bottom. We have sine 2x. That's going to be a pain in the ass. Just trying to get it in the right form for the formula. This one screams do L'Hopital if L'Hopital works. So if you evaluate at 0, we've got sine of 0 over 3 times 0. Those are both zeros on top and bottom. I'm off the screen on it. Yep. So these are miserable, but L'Hopital's makes it pretty easy. You take the derivative of sine of 2x, and you get 2 cosine 2x. And on bottom, the derivative is just 3. And when we evaluate, we've got 2 times cosine of 0. Cosine of 0 is 1. So 2 times 1 on top and 3 on bottom. And so that one's pretty easy. And I'm not even going to waste the time to try to convert that with the formula. So the other ones were about the same amount of time, either way you did it. This one would have been a pain in the ass. Ready for more? If you need up longer, say something, because otherwise it's vamonos. Let's go. Next one says, number 4 says, use the limit definition to find the derivative. You will have a problem like this on the test. I'm off screen. We've got f of x equals x squared minus 3. Anyone remember the definition with limit? Limit as h goes to 0 of f of x plus h minus f of x over h. That's the most common one. There is an alternative, whereas x minus x naught, and then go as x goes to x naught. But that's h going to 0 is much easier to see in your head. So how does this apply to ours? We've got limit as h goes to 0. F of x plus h is going to be everywhere I see an x, I'm going to replace with h, x plus h. So that's my f of x plus h minus f of x. I don't know that I used brackets when I was lecturing on it, but I think if you use brackets to separate f of x plus h and f of x, it might help you collect your thoughts better and keep it organized. It also will help you recognize that this negative needs to be distributed. So, and you should keep writing the limit down until you evaluate at the limit. You should have a limit as h goes on all of these with the limits. Keep doing the limit until you've taken the limit. X plus h squared is x squared plus 2hx plus h squared. Then I have minus 3. That's my first term. And now I'm going to distribute that minus sign and get rid of the brackets. That way I know I've done it. All right, what do we got left? If you've done it correctly, everything that doesn't have an h in it should cancel out. X squared and negative x squared, those cancel out. Negative 3 and positive 3, those cancel out. I am left with 2hx plus h squared over h. And at that point, you can divide the h in. And you have the limit as h goes to 0 of 2x plus h. Which is just 2x. Want to do a check on this one? It's easy. You know how to do the derivative another way. F prime of x dd dx of x squared minus 3 is 2x. So you'll know if you got the right, if you did it the right way, if you just take the derivative the normal way. Is ready for some more? I see some pins still moving. I'll give you a second. All right, number 5. Find ddx 5x minus 2 over 3x minus 1. You have a couple routes. You can do quotient rule. High prime low minus high low prime all over low squared. Or you can do the product rule, which is high, you're doing the derivative high and then L to the negative 1. I think the quotient rule is actually pretty easy here. It's not slow. So I'm going to go with quotient rule. I prime is derivative of 5x minus 2 is 5. Times low is 3x minus 1. Then I have minus high, which is 5x minus 2, times the derivative of low, which is 3. All over low squared. The instructions also say and simplify, which means you don't just leave it like that. We've got 15x minus 5. And then minus 15x plus 6 over 3x minus 1 squared. And it actually just simplifies to 1 on top. Number 6 is a short one. We're given y equals tangent of 2 times 2 to the 3rd power. That fucking came out all garbled in my mouth. Find dy dt. This is a chain rule problem. So when we take the derivative with respect to time, we do the derivative of the outside first. Leaving the inside alone. I'm actually like trying to spell this out because this is something that, at least on the exam that we did this on, and following exam, people were just fucking the chain rule up left and right. So what is the derivative? The outside thing is tangent. 2 times t cubed is on this. I think the problem is having 2 and t. I fucking keep it. It's like a tongue twister for me for some reason. 2t cubed. No, it's not too bad. What's the derivative of tangent? Secant squared. We are going to leave the inside alone. Now multiply by the derivative of the inside. The derivative of the inside with respect to t is 6t squared. So I would probably write this in a final form as dy dt. I would put the 6t squared, that way no one confuses it and thinks it might be part of the secant. Hopefully the chain rule part's gotten a little easier with our substitutions that we've been doing in the integrals. We've had to do a lot of substitutions and you technically are doing the chain rule in it. Hopefully, we'll find out. Speaking of, on the day of the final, next Tuesday, I technically have a class in here with a final after that, but they are taking it in an hour and a half. So when you come in on Tuesday, if you want, you can be here till noon. That doesn't mean show up at fucking 9:30. I'm gonna write down your name. You show up at 9:30, start taking the test late, because I'm gonna be mad. Show up on time. That way you have, there's enough time to finish. All right, you guys ready for more? We're almost halfway through the problem. Maybe 40%. Number 8. Nope, number 7. Let's try number 7 next. Find the equation of the tangent line to the graph of f of x equals 3e to the x plus 1 at x naught equals natural log of 2. All right. Equation of a line. We can do, I think the easiest one to use is y minus y1 equals m times x minus x1. Well, maybe I'll say x0 because I got x0 already listed. We'll say x0 and y0. So I already got part of it. I need y naught and I need m. To get y naught, just evaluate at x naught. E and ln cancel out. That ends up being 3 times 2 plus 1. They're inverse functions. So this ends up being 7. So 7 equals y naught. I'll drop that in right there. And we need f prime of x naught. So what is f prime? F prime of x is 3e to the x. The derivative of plus 1 goes away, and e to the x is its own derivative. It's the pimp daddy function, right? Its integral and its derivative is itself. It says you shall not pass. Now we evaluate that at x naught, which is natural log of 2. So I have 3e to the natural log of 2. We just did that in the first one, and in the y naught is 6. So m equals 6. And I end up with y equals 6x plus 7 minus 6 times the natural log of 2. Everyone ready for some more? 8. Find dy dx for x squared plus y squared equals x natural log of y. Now, if you wanted to do this the good old fashioned way, you gotta get y by itself. But I see a y squared and I see a natural log of y. This is gonna be a clusterfuck if you try to do it explicitly. If you try to do it, get y by itself, you're gonna be fucked. This is an implicit differentiation task. So ddx of x is just 1, and ddx of y is dy dx. That's the idea here. What we do is we take x squared, we take the thing and just take ddx of both sides. ddx, that whole goddamn thing. So there's going to be some product rule action going on in here too. And it's a chain rule. The y squared has a chain, forces a chain rule. The derivative of x squared is just 2x. The y squared one, y is like an inner function here. The square is the outer function. So the chain rule would say take the derivative of the outer, which is the square, which means bring the 2 down and lower the power by 1. And then multiply by the derivative of the inside. The derivative of the inside is dy dx. Equals. If I take the derivative of x first, that's just 1. And it leaves natural log of y. And then I take the derivative of natural log of y. That's a chain rule step going on. The derivative of natural log of y is 1 over y. And then the derivative of y is dy dx. So I'm gonna get all my dy dx's on one side. I'm gonna move them all left, which means I'll take my 2x and I'll move it right. If I do that, I've got 2y dy dx minus x over y dy dx equals natural log of y minus 2x. Everyone good with that step? All right, we factor out the dy dx. And now normally we would divide by this, but I got a fraction in it and I don't like dividing by fractions. So I'm gonna get a common denominator first. Just by multiplying the 2y by y over y. And I will have 2y squared minus x over y equals natural log of y minus 2x. Otherwise, I got fractions and fractions, and that's just sloppy. We multiply by the reciprocal. And I've got natural log of y minus 2x times y over 2y squared minus x. I'm gonna make it one fraction. That's all that's left to do. You got y times ln of y minus 2x all over 2y squared minus x. And if you want to distribute the y, you can. Anyone need it up longer? Right. Number 9. Ooh, weird problem. Oil spilled from a ruptured tank. Ruptured tanker. Spread the oil that spilled from a ruptured tanker spreads in a circle. Whose area increases at a constant rate of 6 miles squared per hour. How fast is the radius of the spill increasing? When the radius is 3 miles. That's my tanker. I don't know why my tanker's got a sail on it. Oil tankers don't have sails on them, do they? But it's clear indication it's a boat. So my oil tanker's got a little rupture on it. Oil shooting out is spreading out. So it looks like it's making a circle. In fact, it says it's in a circle. And it's talking about the area. The area of a circle is pi r squared. Thank you, Dalton. So that gives us that information. Oil in a circle. What does it mean by area increases at a constant rate of 6 miles squared per hour? That looks like a change in the area over time. Change in area over time is dA dt. So that's 6 miles squared per hour. And they want to know how fast is the radius of the spill increasing. So if the radius is increasing, it's changing with respect to time. Change in radius with respect to time is dr dt, which is what we don't know. So we have a equals pi r squared. Let's get those. We don't have time derivatives on either of these yet. So let's take the time derivative of this equation. dA dt equals pi is a constant, so it doesn't need a derivative. Don't do d pi dt and then say it's do a product rule. That's a lot of work. This is pi is constant. So constants can come outside the derivative. In fact, I'm going to write it in 2 steps just to make sure I remind you. The derivative of r squared is 2r. So I'm going to write 2 pi r. And then I got the derivative of r, which is dr dt. All right, so we have a lot of information here. We know the left side is 6 miles squared per hour. Then we have 2 pi times the radius at that time is 3 miles. And we're looking for dr dt. So that's just 6 pi miles. We'll divide by it. If we divide both sides by 6 pi miles, we get just miles per hour left. One of the miles on top cancels with the miles here. The 6 is canceled and we're left with 1 over pi. I have no idea what that is. What is 1 over pi? Close to 30% or so. And we got a handy calculator. 0.3 something. Thank you. You guys ready for the next one? That's what we were looking for. dr dt. So that was our, well, including the 1 pi. 1 over pi works as well. That's the more accurate answer. All right, number 10 is probably the problem that's going to take you the longest on the test. Graph the following. And it says label all relative extrema. Asymptotes. Inflection points. And intercepts. It explicitly tells you to make sure that you do a sign chart. For all 3 parts. And be accurate with respect to concavity. I had to add that sign chart thing all for Cohen. Couple others didn't like to do side charts either, but that was all for you, Colin. You're welcome. Prompt your hand, make it clear. I expect to see it. All right, so y equals x minus 1 squared over x squared. And then I gave you the first two derivatives, not time derivatives. We've got 2x minus 2 over x cubed. And oops. And then y double prime is 6 minus 4x over x to the fourth. After you do the derivative and clean it up, simplify it, that's what it looks like. So let's label them A, B, C. Let's see what we can get from each of them. A, I should be able to get the intercepts and asymptotes. So x-intercept is when y equals 0. And y equals 0 makes it so we have 0 equals x minus 1 squared over x squared. That only equals 0 when the top equals 0. And the top only equals 0 at 1. You take the square root, solve, you'll get 1. Maybe I better show it for Colin. Make sure you don't slack on me. Y-intercept is when x equals 0. Zero squared on bottom is a problem. This is undefined here. This tells us we have a vertical asymptote at x equals 0. And it's the only vertical asymptote. We don't have anything else on the bottom that'll make the bottom 0. Horizontal asymptotes are what happens when the limit goes to infinity. Limit as x goes to plus or minus infinity, really, of x minus 1 squared over x squared. And there's a couple ways you can do it. You can recognize that this is a L'Hopital scenario. So you can take the derivative, and you already have the derivatives listed. Here, I'm just going to break it up. 2x over x cubed becomes 2 over x squared. And this is 2 over x cubed. Is that what I want to do? This still ends up being 0 minus 0 doesn't help. So maybe let's do this a different way. This is x squared minus 2x plus 1 over x squared. Back to the original one. Multiply by 1 over x squared on top and bottom. And when you evaluate at plus or minus infinity, those go to 0. And we get 1. 1. I wrote 0 and I meant 1. So our horizontal asymptote is y equals 1. Yeah.
That's like the whole ratio.
What does the what?
Yeah. Like. The exponents on the top and bottom, like the same.
So when the exponents are the same on top and bottom, you're gonna have a horizontal asymptote. If the top is bigger by 1, you're going to have an oblique or slant asymptote. If it's more than 1, it just skyrockets to infinity at a rate that you can't really track very well.
But it's the same as like the ratio. Coefficients.
Yeah, it's the ratio of it's the ratio of these coefficients. Most people don't remember that. So I was using a tool that everyone remembers, hopefully, how to solve a limit. But yes, it is the ratio. When they are matched, it's the ratio of the coefficients of the leading terms on top and bottom. Which would save you some time. If you recognize that, it saves you some time. We had x equals 1 and y equals 0. So we have a vertical asymptote at x equals 0. I'm going to just cluster all my information that I got from this one together. And I got an x-intercept at 1, 0. That was everything we got from part A. We'll do a sign chart real quick here. The only points in question are 0 and 1, where the top equals 0 and the bottom equals 0. So if I test like -10, off screen, right? -10, if I stick it into y, -10 minus 1 squared over -10 squared, positive over a positive is positive. In fact, it's a square over a square. Smiley face squared over frowny face squared. They're both positive no matter what. So the graph is always greater than or equal to 0. There is no negative components there. And we know it goes down to 0 because we have an x-intercept. Sign chart's pretty helpful. We already narrowed down, we can eliminate half the goddamn graph. I don't need to make it so big. All right. What do the other derivatives give us? So we have y prime equals 2 to, I'll factor it here. From this one, we can get our inflection points. And regions of increase and decrease. That's not our inflection points. Those are our critical points. Regions of increase and decrease. So where is it increasing? Where is it decreasing? Again, the only spots we have are 0 from the bottom and 1 on top. If I try -10, 1/2, and +10, -10 minus 1 is a negative. -10 cubed is a negative. This is a negative over a negative, which makes less than 0 positive. So we're going to have our graph going something like this. Oh, we can also find our extrema here. This is a good spot to find extrema. One half, if I stick in one half, the top is negative, but the bottom is positive. So this is a negative region. And if I stick in 10, they're both positive. We know x equals 0 is an asymptote. So our graph's going to have something like this. So there's no max there, even though the sign chart would say there's a max. There's an asymptote there, so there's no max. But here it looks like we've got a relative min here. And we actually already identified this. This was our x-intercept. If it wasn't already identified, you'd need to label to find that y value for it. Maybe I'll walk through that just because. So, relative min at x equals 1. To find y, go back to original equation, y equals x minus 1 squared over x squared, and evaluate. Y equals 1 minus 1 squared over 1 squared is 0. So we get the point 1, 0. I remember on this test, people were trying to find it by plugging into y prime. And you can't find the point by plugging into y prime. Well, in this problem, you actually could. It would still give you a 0, but that's coincidence. So we know where it's increasing. Increasing from negative infinity up to 0. 0 is an asymptote. And it's also increasing from 1 to infinity. It's decreasing from 0 to 1. And 1, 0 is a relative min. There is no relative max, apparently. So that's what we got out of y prime. Y double prime was 6 minus 4x over x to the 4th. Let's see, our inflection, where are our critical points at? The top, set that equal to 0. I got 6 equals 4x, divide by 4. X equals 6 over 4, which is 3 halves or 1.5. The bottom gives us x equals 0, which we know is an asymptote, so that ain't gonna be it. But checking here will give us our concavity. So I'll try negative 10, 1, and 10. Into y double prime. If I stick in a negative number, 6 minus 4 times a negative is 6 plus 4 times 10. The top is positive, the bottom is positive, this is positive. It's concave up there. At 1, if I stick in 1, I've got 6 minus 4 is 2. And on bottom, I've got a 1. This is positive also. So it's concave up from 0 to 1 to 5. And if I stick in 10, the top is negative, but the bottom is positive still. So it's concave down. So we're concave up from negative infinity to 0 in union with 0 to 1.5. And we're concave down from 1.5 to infinity. So x equals 1.5 is going to be an inflection point. We can find the y value by plugging into the original equation. So we had x minus 1 squared over x squared. So 1.5 minus 1 squared over 1.5 squared. Let's say I did this. 1/9. Let's see, that's 1/2 squared, so 1/4 over 3/2 squared over 9/4, 1/9, yeah. So we have an inflection point at 3/2, 1/9. All right. I think we're ready to graph. We have found the relative extrema. Relative extrema was here. We were supposed to find the asymptotes. We found the asymptotes on page 1. We found the intercepts. And we found the inflection point right now. So let's just plot that shit. It makes it kind of easy that the graph was greater than 0 everywhere. So I don't need to like draw a big ass picture. So where were our, let's see, we have a vertical asymptote at x equals 0. And we have a horizontal asymptote at y equals 1. Horizontal asymptotes can be crossed in near the middle of the graph, just at infinity, they don't get crossed. We had an x-intercept here. We had an inflection point at 1.5, 1/9. That's a rough one to draw. Scaling 1/9 is fucking a little hard to do by hand. I'm just gonna estimate it's about there. We know it's increasing till there, it's decreasing till the intercept, and it's increasing here. We can actually find where it crosses the horizontal asymptote, which might make this sketch a little bit better. Where does it cross HA? Of y equals 1? Well, set the original equation to that and solve. I get x squared equals x minus 1 squared. So only at x equals 1/2. Subtract 1. So it only crosses right here. We know it's concave up here, it's concave up here, and concave down there. All right, so concave up here, and it's got to keep going up, and it doesn't cross the horizontal asymptote over here, means it's got to be doing something like this. It doesn't go below it. It doesn't cross it over here, and it's always going up. It's always increasing because of the slope, and it's concave up. So that gives us the left side of the graph. Here it's decreasing until 1, and it's concave up right there too. And it's still concave up until we get to there. So that's concave up. And now it pivots to concave down. And we don't cross the horizontal asymptote anymore, so it's going like that. And if this curve looked a little bit better. So seeing as how long that one took, I would recommend doing that last. Because all problems are worth the same amount of points. Yeah.
We're increasing. Not like on calories.
Yeah. It's still increasing, although it's approaching that horizontal asymptote. It's increasing very fucking slow. Because it never crosses 1, but it's still got to keep going up. Which means while it's going up kind of quick here, eventually it's going up 1/1,000,000th over like fucking 1,000,000,000 or whatever. I don't know. The math would show us if we worked out like how quickly it was changing later on. I will tell you now on the test, there are 16 problems. And the instructions, if you read them, they don't say it on the practice, but when you read them on the test, it says you may choose to skip one. If you do, right, skip this one. If you do them all, it'll be, one of them will be extra credit. Now, I'm suspecting a lot of people are going to skip the graphing one because it's long. But it's not that hard to do. And if you struggle on another one, you don't know how to do another one, don't skip the one you know how to do, the graphing. Even if it is long. So your extra credit one, your extra credit problem is doing the 16th problem. So if you do them all, then that's your extra credit. All right, that was number 10. You guys need a 5-minute break or anything? Anyone need to go pee? All right, let's keep going. Number 11. A rectangular plot of land is to be fenced using 2 kinds of fencing. Two opposite sides. We'll use heavy duty fencing. That sells for $3 a foot. The remaining sides use standard fencing. At $2 a foot. What dimensions yield the greatest area? If the cost of the project is $6,000. Yeah, but there's other problems you might want to skip. Some people, everybody hates word problems. This one's doable. It's gonna make you think. Let you write it down. We'll just go walk it through it together. Because I started barking up the wrong tree the first time I did this too. What are our usual go-tos for rectangle problems? What equations do we have for rectangles? Area is length times width. What else do we normally use? Perimeter. 2L plus 2W. And that threw me off for a long time because they gave no information about the perimeter. So we actually don't need that equation. It's not helpful. We have zero information regarding perimeter. They're not asking us to find the perimeter, so we don't need it. So maybe I'll draw a little picture. I could say length and width, but they tell us two sides, opposite sides are heavy. And two sides, the remaining sides use standard fencing. And I tried to stick with L and W for a while, and I go, which one's the $3? Which one's the heavy fucking side? Which one uses the heavy duty fencing? That's going to change what I do. And then, like a dumb shit, tried to work with that for a while, fucking got nowhere. I'm like, I don't know what to do. And then I go, why don't I just relabel these heavy times standard? And so area becomes H times S. So don't think of it in terms of length and width. Think of it as heavy side versus standard side. We have an equation for this, for cost. We know heavy side is $3 a foot. Standard side is at $2 a foot from the problem. And I guess perimeter actually does come in. Perimeter sneaks in here. The cost of the fencing is going all the way around. We need 2H times its cost plus 2S times its cost to equal the $6,000. So perimeter sneaks in a different manner. I guess we did need that. I guess I didn't need to cross it off. Yeah,
So like, we wouldn't really need like the area. There's usually.
and that's what we're looking for. We're looking for the greatest area. So if I clean this up a little bit, I've got 6H. I'm gonna drop the dollar signs for now. Ah, fuck it, I'll leave them in there. 6H plus 4S equals 6,000. It doesn't matter which letter you solve for, we want to get A down to a single variable. Because if we do, we can take the derivative and find the relative max. So I'm going to solve for S here because I like the 6 going with the 6,000. And so S equals and the dollar signs go away at this point. They all cancel. So 6,000 minus 6H over 4. That does simplify, but I'm not going to bother. I'm just going to take it and stick it into A. So A becomes H times 6,000 minus 6H over 4. So maybe I will simplify. This actually gets helpful. So that is H, 6,000 divided by 4 is 1,500. And then we've got 1.5H. And rather than trying to take the derivative as it is, I saw some students do this on the test because you have to do a product rule here to take the derivative. Multiply that motherfucker out. And now take the derivative. So DADH. DDH of both sides. We saw from looking at A right here, 1,500 minus 1.5H squared. Negative H squared is a downward opening parabola, so it will have a max somewhere. So that's what we're going to find using doing this. We set this equal to 0 to find that spot. 1,500 equals 3H. So H equals 500 feet. It was in terms of feet. That's how many feet of heavy duty siding we needed. S was 6,000, well, 1,500 minus 1.5 H or 1.5 times 500. This is 15,000 minus 750. So S equals 750 feet. Those are the answers because it asked specifically what dimensions. It didn't ask me what the area was. It asked what the dimensions were. So those are the dimensions. You can plug them into this price equation and verify that you still get $6,000. That's worth checking. When you're doing the test, if you've got time to check it by plugging into your equations, check it. Rest is quick. You look at 12 onward, we are looking at integrals. And I think everyone that I actually spoke to since Tuesday said this test was easier. Well, if you studied for it appropriately. Some people took it too easy. We won't say any names. I only graded one test. I'm grading them today. Hopefully I have them up tonight. I need to grade Seaside Computer Science 2's exams first. There's only like 18 students and they're just kind of quick. I'm doing final exams for my stats classes for the rest of the day, so I plan on doing grading. And I hope to have your exams from Tuesday up tonight. If I don't, they'll be up tomorrow afternoon. You guys ready? Look at number 12. Number 12 is find the integral of sine of 3x, cosine of 3x, dx. So I don't know how to do this as is, so I'm going to make a substitution. Which one do you guys want to substitute on? What? So if I substitute 3x, I'm still stuck with my problem. But it's not a bad idea. There are ways to work with this where it's not a problem anymore. But let's say you did u equals 3x, so you get du equals 3dx. So 1/3 du equals dx. Now your integral is 1/3 sine u cosine u du. So did that help? Depends on what you want to do with it. If you want to recognize that sine of 2u equals 2 sine u cosine u, this is really helpful because we're down to u. We don't have 3x in there. We got a u. You could use that. I don't have 2 sine u cosine u. I only have sine u cosine u. So I got to divide by 2. This would be 1/2 sine of 2u on the other side. And that would make this integral 1/3 times 1/2 sine of 2u du. Then integrating, now I gotta do another sub on the 2u because we don't integrate sine of 2u. But so we could do this, go this route. We'd have to do like a w equals 2u and do another replacement. I'm gonna go back and say, let's try something else. Why don't we just pick one of the trig functions to be the u sub? I can look at both and see which one I like. If I say u equals sine of 3x, then du equals cosine of 3x times the derivative of the inside is 3 dx. Or I could say u equals cosine 3x. The derivative of cosine has a negative though, and I'm not a fan of the negative. Negative just is an opportunity to fuck up. So I'm going to go with this one. And I I can move the 3 over. 1/3 du equals cosine 3x dx. And that's my u. And this is 1/3 du. So I have the integral of 1/3 u du. Up power, divide by power, divide by the power, plus the constant of integration. When you do not have limits of integration, you have to have a constant of integration. So I've got 1/6 u squared plus c, but I did not start with u, and so I am not going to end with u. And about you. It's cheesy.
With the square, with the 3x, you put it in the sign.
Yes, because it's not the 3x getting squared, it's the sine getting squared.
Okay.
Another way of writing it is so that way it's a little clearer that that's u squared. But we tend to write it like this. Ready for more? Sorry, Jose, I didn't see your comment. He said cosine 3x earlier for the recommended sub. If you type in chat, you risk not being heard. For Lowell, you won't be heard at all because it doesn't make sound, but you know what I mean. All right, so we have options. We could go down in a fucking blaze of glory and expand this all out and have one giant fucking polynomial. We could. There are ways to do this that don't require a substitution. Fuck all that. What should I substitute here? Let's say u equals 2 minus 5x squared. You know what? I'm tired of using u. I'm going to use w. I'm changing shit up. You know what? No, fuck that. We're going smiley face. Because we can't. I want to make it clear to you, variables are not the fucking important thing as long as you label what the variable is. So d smiley face dx is negative 10x. I'm going to just say d smiley face. That's the right way to do this. Differentials. And I've got the x, but I don't have the negative 10. So I'm going to write x dx equals negative 1/10 d smiley face. So I have the integral of smiley face to the 7th power. And I can put the negative 1/10 outside and then d smiley face. So smiley face is our variable. We integrate the smiley face. We go up a power. We have the negative 1/10 outside. We go up the power to 8 and then divide by the power. So 1/8 out front. And plus c. And we didn't start with smiley face, so we're not going to end with smiley face. We started with 2 minus 5x squared. After writing smiley face in the integral, I regret doing it. Smiley face is more easier with a derivative than it is on an integral. It looks funny there. So do the graphing one last, because it does take the longest. I know if when I measured the time, I measured how long it took me to do the graphing. It was like 12 minutes or something like that. And all of the other questions combined took me like 30 minutes to do. Because I've got more practice on doing this stuff than you guys do. But having said that, you guys should be able to do it all in 2 hours. We got a couple more. Number 14 says, do this one 2 ways. I've got t squared times the square root of t cubed plus 1 dt. And it says, do a 1a by changing the limits. And b, keeping limits with t. Okay. What's my u sub look like here? Dalton? That looks like a good u sub to me. So du equals 3t squared dt. And 1/3 du equals t squared dt. So that's my u, and these two are my 1/3 du. So on A, I change the limits. When t equals 0, u equals 0 cubed plus 1, which is 1. And when t equals 1, u equals 1 cubed plus 1 is 2. And I'm making that decision from my substitution. So my interval will go from 1 to 2 instead of 0 to 1. And I have a 1/3 u du. We integrate this. It's u squared and then a 1/2. We're evaluating from 1 to 2. Make sure you show all this stuff. So this is 1/6 u squared from 1 to 2, which is 1/6 2 squared minus 1 squared. Alternatively, you can say 1/6 times 2 squared minus 1/6 times 1 squared. But as soon as I fucked it up. Let's try that again. You're right. Good catch. Limits are still the same, 1 to 2. That is 1/3 u to the 1/2 du. Excellent catch. So upper power here goes up to 3/2. Multiply by the reciprocal, I got 2/3. And we're doing from 1 to 2. So I've got 2/9 u squared from 1 to 2, which is 2/9 times 2 squared minus 2/9 times 1 squared. I think that's the harder way of looking at it, because you got a lot of 2/9 going on. I think if you look at this part like that, with the constant out front. You got 2/9 and then 2 squared minus 1 squared. I got less fraction shit going on. The fraction happens at the end. I think that's easier. In both circumstances, you are going to get 6/9, which is 2/3. Let's go back to keeping the limit the same.
Who's the power of? We,
Did I do it fucking again? Jesus Christ.
Yeah, I was gonna say, isn't it the power of 3/2?
Fucking scrub alert. Jesus. All right, let's try this again. One more time. I was gonna find out real quickly when I did it the other way and got a different answer. I know that. 2/9. 2 to the 3/2 is 2√2. Because 2 to the 3/2 is 2 to the 1 plus 1/2, which is 2 to the 1 times 2 to the 1/2. So I think you can see it that way. And I think that's worth leaving as is. No point in writing it out. That's the exact answer. It's precise. This is one of the reasons why I have you do it both ways on this. So if you fuck up and pull a Jones, you fucking catch it. If you do the other one, you're like, if you get different answers, one of them, or maybe both, you did wrong. But you at least gotta double check them both. If I go the other way, I'm keeping the limits the same. The fuck? Since I'm going to use U, I'm going to write my limits with a T in them to make it clear that I'm off screen. This was 1/3 U to the 1/2 du. When you keep the limits the same with the same old letter, make sure you indicate that they are the old letter. Otherwise, it looks like they belong with the new letter and it's wrong. So we saw this was 2/9 U to the 1/2 from t = 0 to t = 1. Now we make our substitution. I should say 3/2. I keep fucking doing it. I keep trying really fucking hard to call that a square. Really, really fucking hard. Now that I'm back to t, I don't need to write the t anymore. One cubed plus 1 to the 3/2 minus 0 cubed plus 1 to the 3/2. That is 2 to the 3/2 minus 1 to the 3/2, which is that. Number 15. I didn't label that problem. That was number 14. So these will be up on a slide. I got 2 more problems to go, so I want to get it done I didn't fuck it up twice there, we would have been all right. Number 15. -2 to 2, the absolute value of x cubed plus 1 dx. The absolute value of x cubed plus 1 is like this. Which means from -2 to -1, it's negative. So what we need to do is we need to split this up. Because remember, absolute value of u is u if u is greater than 0. And negative u if u is less than 0. So we're doing the u is less than 0 from -2 to -1. We're going to switch to the -1 there. And I'm going to say negative x cubed plus 1 dx. And then we're splitting it up into two regions. The other region, it's positive. So we integrate both of them. This is 1/4 x to the 4th plus x. And I recommend you go slowly when there's fucking negative signs. I've got negative 1/4, the upper limit . No, I had it the way I wanted it. We'll make that a big fraction right there. Minus, and then we got negative 1/4. -2 to the 4th. That's the first bracket. (1/4) 2 to the 4th power plus 2 minus 1/4 -1 to the 4th power plus -1. All right, so -1 to the 4th power is 1 times 1/4 is 1/4 plus -1 is -1, and I've got a negative. This first term, this is -3/4, and I got another negative. The first term is 3/4. Then I got a plus 1/4. -2 to the 4th power is 16. Plus -2 or -2. 1/4 of 16 is 4. 4 minus 2 is 2. And I got that here, plus 1/4 of 16 plus 2 is 4 plus 2 is plus 6 for the next term. And finally, I've got minus 1/4 minus 1, which is another plus 3/4. So 3/4 and 3/4 is 1.5. I've got 8 plus 1.5 is 9.5. If you write it out like this with parentheses like this, you will see wherever you had a repeated limit, like -1. -1 was the 3/4 and -1 was the 3/4 here. And since we're switching sign with the absolute value, they both ended up being positive. They don't cancel each other out. So pay attention to the signs. Pain in the ass, right? Number 16. F of x equals 2 to the x, not 2 to the x, integral from 2 to x of secant squared t dt. And it says, A, find f prime of x, which is d dx of 2 to the x secant squared t dt. And it says using the fundamental theorem of calculus part 2. When we do that, this just evaluates it at x. Whatever the d dx and the dt go away, whatever this is comes in here. Unless it's something awkward, then you gotta do the chain rule thing that we did like at the end of the last lecture. And I'm pretty sure I didn't fuck you guys like that on the exam. Well, it's not fucking you, it's just up again a notch. Then it says part B, show it by hand, show it working it out. So if I integrate secant squared, what's the derivative? What derivative is a secant squared? Tangent, right? So we've got tangent of t evaluated from x to 2, which is tangent x plus tangent 2. So that's f of x. And so when we take f prime of x, we just have the derivative tangent x plus tangent 2. And tangent 2 is a constant. So the derivative of a constant goes away. The derivative of a tangent is secant squared. And this is why we don't have the constant here. At least one student I know of, skimming through it, tried to add a constant to the fundamental theorem of calculus for this part, and it doesn't have it. So we got secant squared x either way. That's all the problems. On Saturday, I'm in the Mesa Center from 9 to 12. John Muir Building. If you come into the parking lot right next to the building, you'll see the open door. You can find me. If you want any extra like study time or questions that I'm not answering fast enough or you want to do in person. Otherwise, I will see you on Tuesday. I'll have this scanned and the answer key uploaded pretty soon. Well, probably around noon. Well, probably afternoon, because I got a Zoom meeting at noon.
Real quick, isn't it? I think. I think it's on my wall.
Yeah, it is minus. Good catch.
And it's. The bracket question, when you were drawing the graph. How do we know like not under here?
Because we checked where the horizontal, where it crossed the horizontal asymptote right here. And it only crosses it at x equals 1/2. So it only crosses here. We know it's gotta keep going up. And if it keeps going up below it, it's gonna, where does it go when it gets to here? It can't keep going up. And it can't cross the asymptote.
Okay.
That's kind of how.
Was it for you, you uploaded like a lecture?
Yeah.
Okay, alright.
I have, I got a test till noon and then I got a Zoom meeting from 12 to 1, but I should have it up shortly after that.
And I also looked at the concave, right? To like.
Yeah,
Oh, okay.